All right, let's jump right in. There's a massive and kinda quiet revolution happening out on the high seas. And it's not about pirates or anything like that. It's about something way more fundamental. What's actually powering the giant engines of global shipping? We're talking about a complete strategic evolution of marine propulsion, and it's happening right now.
Just think about the phone in your pocket, the car you drive, the coffee you drank this morning. Chances are, most of it, or at least parts of it, crossed an ocean on a container ship just like this. This isn't just some niche industry. It's the circulatory system, the lifeblood of the entire global economy. And that means the fuel choices it makes have a truly planet-sized impact.
So here's how we're going to tackle this. First up, we'll get into the why. What's the green imperative that's forcing this huge change? Then we'll look at the industry's first big answer, LNG. After that, we need to talk about a really tricky complication called methane slip. Then we'll meet the titans of industry, the companies actually building these new engines. And finally, we'll peek into the future and look at the high-stakes race to find the next generation of fuel.
Okay, let's start with the immense pressure that the entire industry is under. And you gotta understand, this isn't some voluntary, feel-good shift. No way. This is a global push for cleaner seas, and it is all being driven by some very, very serious numbers. And when I say serious, I mean the scale of this is staggering. Think about it this way. If global shipping were its own country, it would be one of the top polluters in the world. And here's the real kicker. As other industries start cleaning up their act, shipping's slice of that global emissions pie is on track to get alarmingly big if things don't change, and fast. So who's making the rules? Who's forcing the change? Well, the whole industry basically answers to one organization, the International Maritime Organization, or the IMO. They're the UN's agency for shipping, and they have laid down new laws that are forcing a major strategic rethink for every single ship owner on the planet. And let me be super clear, these are not just friendly suggestions. These are binding, hard and fast regulations with a very strict timeline. Ships are now graded on what's called their greenhouse gas fuel intensity, which is really just a fancy way of saying how much pollution they create for the power they use. Hitting these targets is absolutely non-negotiable, and it's forcing massive investment in new engine architectures and much cleaner fuels. Okay, so you've got these tough new rules looming. What's the industry's first big move? Well, for a whole lot of ship owners, the initial answer was liquefied natural gas, or as you'll always hear it called, LNG.
And you can see the appeal immediately, especially when you compare it to the traditional stuff, which is this thick, sludge-like heavy fuel oil. I mean, on pretty much every environmental metric that matters, from greenhouse gases to the nasty pollutants that harm our health, LNG is a huge step up.
Just how big of a step are we talking? Well, one major study found that the total greenhouse gas impact of that old heavy fuel oil is more than 2 times higher than LNG for the same energy output. That is a massive improvement right out of the gate.
And you can see this playing out in the market dynamics. If you look at the new ships being ordered today, LNG is the clear leader among the alternative fuels. It's capturing a full quarter of the market. It has really become the go-to bridge fuel as the industry starts down this long road to decarbonization.
But, and you know there's always a but, LNG is not a perfect solution. It comes with a very specific, very slippery problem that engineers are working tirelessly to solve.
That problem is called methane slip. So here's the deal in simple terms. LNG is mostly methane, and what can happen is a tiny fraction of that gas can actually slip right through the engine without getting burned and just vent straight into the atmosphere. Now, you might be thinking, a tiny leak, what's the big deal? Well, here's why it matters so much. Methane is a super potent greenhouse gas. Over 100 years, it's more than 25 times more powerful at trapping heat in the atmosphere than CO2 is. So that means even these small amounts of methane slip can seriously start to chip away at the climate benefits of switching to LNG. It's created a high-stakes race to solve this critical engineering challenge. So where is this slip coming from? Engineers have pretty much pinpointed 2 main culprits. First, there's something called valve overlap. For a split second, both the intake and the exhaust valves are open at the same time, and some of the unburned gas can just get pushed right out. The second cause is just incomplete combustion. Tiny little nooks and crannies inside the cylinder can trap a bit of fuel that doesn't burn completely, and it gets released in the exhaust.
And you can imagine just managing these new fuel systems is a huge engineering challenge. Teams do these incredibly detailed safety analyses, like this one, an FMECA, where they go through every single component, every valve, every pump, every sensor, and they figure out what could possibly fail and what would happen if it did. It's a painstaking process, but it is absolutely vital to making sure these systems are safe.
So all of this massive technological shift, it's really being driven by just a handful of incredibly powerful engineering firms. These are the engine builders, the real titans of this whole transition.
What's really interesting is that each of these key players has a different strategy, a different portfolio. You've got giants like Wärtsilä, who are developing a whole suite of different solutions, even onboard carbon capture. Then there's an innovator like WinGD, who's really pioneering engines for future fuels like ammonia. Yanmar is laser-focused on solving that methane slip problem we just talked about. BeHydro is betting big on hydrogen. And then, of course, you have the heavyweights, Hyundai and MAN, who pretty much dominate the market for those giant two-stroke engines that power the world's biggest ships.
The global footprint you need for this kind of shift is just enormous. To design, build, and then service these complex new propulsion systems, these companies need a whole network of engineering sites, manufacturing hubs, and service locations that span the entire globe. This is a truly worldwide industrial transformation. So, if LNG is the bridge, where is that bridge actually taking us? The industry is already looking way past it, towards the ultimate destination, zero carbon fuels.
And the technology here is evolving at an incredible pace. I mean, right now, engines are already available that can run on methanol. Next year, in 2025, we're expecting to see the first engines that can run on ammonia. And if you look out beyond 2030, hydrogen and so-called e-fuels, which are synthetic fuels made with renewable electricity, are expected to really start scaling up. The engine builders are making sure the tech is ready.
This strategic evolution that's coming is just dramatic. Yeah, in the short term, fossil fuels like LNG will still be the main players. But fast forward to mid-century, and the projections show the industry running almost entirely on a whole new generation of carbon-neutral and zero-carbon fuels. The shift is going to be massive.
And what's really become clear is that there isn't going to be one single solution, one silver bullet. The future is a whole portfolio of technologies. We're going to see things like onboard carbon capture, literally scrubbing CO2 from the exhaust. We'll see those dual-fuel engines ready to run on hydrogen or ammonia. And for smaller vessels doing shorter routes, we're going to see a huge increase in hybrid and all-electric systems.
Which, of course, leaves us with the big question. What we are all watching is this incredibly high-stakes technological race. Market dynamics are shifting, brand new technical architectures are emerging, and manufacturers are placing huge bets. The outcome of this race isn't just going to decide the future of shipping. It's going to have a major impact on the future of our planet. So which fuel, which technology will ultimately win? Well, that's a story that is still being written, right now, out on the world's ocean.